Every year, the world generates over 1.9 billion metric tons of scrap metal, enough to build 20,000 Eiffel Towers. But here's the surprising part. Less than 30% of that metal is recycled. Billions of dollars in valuable resources just tossed away. What many don't realize is that metal is all around us. From soda cans to outdated electronics, scrap metal is everywhere. That scrap metal you're ignoring might just be the foundation for the next sleek vehicle rolling off the assembly line. Imagine walking down the street and seeing a car that was once your old dilapidated fence or that broken bike you tossed out years ago. So how exactly does this transformation happen? Well, hold on tight, because I'm about to break it down step by step. Step 1. Hunt for scrap. Before any metal gets its glamorous second chance, it needs to be tracked down like a lost treasure. This is where the collection process kicks off. Old appliances, cars that have seen better days, and even that pile of cans you meant to recycle ages ago all get rounded up from places like construction sites and garages. Now, everything from copper wires to aluminum cans is hauled in. But wait, the true challenge isn't just finding the metal, it's separating the ferrous from the non-ferrous. And here's a juice bit. Non-ferrous metals are the real moneymakers. They're easier to recycle and fetch a higher price, but make up a smaller percentage of the overall scrap. Doesn't it make you wonder? Why is it the good stuff is always harder to come by? Collecting scrap metal isn't just throwing things into a pile and calling it a day, it's a full-blown operation. We're talking about trucks, ships, and occasionally some confusing international rules. Scrap hunters, companies and individuals alike, are on a never-ending quest for these valuable bits of metal. And with sustainability becoming a buzzword, it's almost like a global race to make sure not a single scrap ends up in a landfill. Now, before we melt down this content into something shiny, smash that subscribe button. We can't turn your scrap metal into a Tesla, but hey, you'll know what to do with all that scrap metal lying around. Step 2. Sorting. Once the metals are collected, the next phase involves sorting. But here's where things get tricky. Metals must be separated based on type, quality, and sometimes even chemical composition. What might seem like a pile of junk to most is actually a gold mine of different metals waiting to be classified. The importance of sorting cannot be overstated. If you have impurities in the mix, the recycled metal will lose its strength or become too brittle for certain uses. At large recycling plants, powerful magnets and sensors are used to detect and pull out metals from heaps of waste, ensuring nothing is overlooked. Ferrous metals, which contain iron, are attracted to magnets and can easily be sorted out. But non-ferrous metals like copper and aluminum require more advanced techniques, such as eddy current separators. In some cases, sorting can even be manual. Workers will sift through scrap metal, hand-picking valuable materials that need special treatment. Step 3. Shredding. After sorting, the metal undergoes shredding, where large metal pieces are reduced to smaller, manageable sizes. Think of giant machines that can rip a car to shreds within minutes. These shredders are absolute beasts, turning hefty chunks of metal into bite-sized pieces ready for further processing. But why shred metal in the first place? You see, shredding serves several important functions. First, smaller pieces have a larger surface area, which means they melt faster and require less energy during the next stage of the recycling process, melting. Second, shredding ensures that any lingering contaminants, such as dirt or paint, are easier to remove. Different metals are shredded in different ways. Light metals like aluminum and copper are often broken down into chips or flakes, while heavier ferrous metals, such as iron and steel, are hammered into cubes or chunks. Either way, the end result is the same, a pile of metal that's much easier to handle, transport, and process. Step 4. Melting. Once shredded, the metal is ready to be melted down. It may surprise you to know that each type of metal melts at a different temperature. For instance, aluminum melts at around 660 degrees Celsius, while steel needs a blazing 1500 degrees Celsius to turn liquid. The melting stage occurs in large furnaces specifically designed for each type of metal. The goal is simple: reduce the solid metal into a molten form that can be purified and reshaped into new products. During this phase, energy efficiency becomes a key concern. Some recycling plants use renewable energy sources such as solar or wind power to fuel the furnaces, ensuring the process is both environmentally friendly and cost-effective. Melting scrap metal isn't as simple as just throwing it into a furnace. The process needs to be carefully controlled to ensure impurities are removed and the molten metal is kept at a consistent temperature. Any mistakes during this stage can ruin the entire batch, turning what could have been high-quality recycled metal into a subpar product. Step 5. Purification. Now that we have molten metal, it's time to purify it. Purification ensures that the recycled metal is as close to its original state as possible, free from contaminants that could weaken its structural integrity. The process varies depending on the type of metal. For example, electrolysis is commonly used for aluminum, while steel might go through a process called oxidation, where oxygen is blown through the molten metal to remove carbon and other impurities. Now, why is purification so critical? Well, without it, recycled metal can't compete with newly mined material in terms of strength or quality. Impurities in the metal can cause all sorts of problems down the line, from corrosion to weakened structure, making the metal less useful in new applications. Some recycling facilities even have advanced technologies that test the metal's composition during purification. These systems ensure the recycled product is just as durable and high-performing as its non-recycled counterpart, which is crucial in industries like construction and automotive manufacturing. Step 6. Solidification. After purification, the molten metal is poured into molds, where it cools and solidifies into ingots or bars. These are the building blocks for new metal products. At this point, the once discarded scrap metal has been completely transformed, ready to be reused in countless applications. The solidification process is more than just about letting the metal cool. It's about shaping it into forms that are useful for manufacturing. These ingots or bars can later be rolled, stretched, or cut into various sizes depending on what they will be used for. For example, steel bars might be cut down for construction beams, while aluminum ingots could be rolled into sheets for packaging materials. Now that the metal has been shaped and cooled, it's time to transport it to manufacturers who will turn it into new products. This step may seem simple, but logistics play a huge role in determining how quickly and effectively recycled metal gets back into the market. Transportation methods vary based on the type of metal and the distance it needs to travel. For instance, large quantities of steel might be transported via freight trains or cargo ships, while smaller batches of aluminum might travel by truck. Step 7. Remanufacturing. Once the recycled metal has reached its destination, the final step of the process comes into play: remanufacturing. This is where the recycled material is transformed into products that can be used in industries ranging from construction to electronics, automotive, packaging, and even art. The versatility of recycled metal is astounding. What was once a discarded car, demolished building, or old wiring can now be molded into something completely different, often with equal or superior quality to products made from raw, virgin materials. Manufacturers use the recycled ingots or bars to produce a wide range of products. For instance, steel may be melted down again and rolled into sheets used for car bodies, construction materials, or appliances. Aluminum is often used for beverage cans, window frames, or aircraft parts due to its lightweight and strength. Copper, known for its excellent conductivity, is often turned into wires or plumbing materials. Each type of metal has its own specific uses, and the products created are typically indistinguishable from those made using newly mined metals. But what makes remanufacturing from recycled materials so attractive? First, there's the cost factor. Recycling metal is far cheaper than mining and processing raw ore. Mining is not only expensive, but also incredibly energy-intensive and environmentally damaging, requiring large-scale excavation, chemical treatment, and transportation. On the other hand, recycled metals are already in a refined state, meaning they can be melted down and reshaped with far less energy and environmental impact. Some estimates suggest that recycled steel saves up to 60% of energy compared to producing new steel from raw materials, while recycling aluminum saves as much as 95%. By reducing the need for mining and conserving natural resources, recycling helps to lower greenhouse gas emissions, minimize pollution, and decrease the environmental footprint of industries that rely heavily on metal production. As governments and corporations worldwide prioritize sustainability, the demand for recycled metal is only set to increase. In fact, some architects and builders specifically seek out materials made from recycled metal as part of their commitment to green building practices. In the automotive and aerospace industries, lightweight recycled aluminum is prized for its ability to improve fuel efficiency without compromising strength, helping companies meet increasingly stringent emission standards. What's your take on recycling scrap metal? Necessary or overrated? Share your opinion in the comments. If you enjoyed this video, give it a like and hit that subscribe button for more.